Hi, this is Hasnan, and today in this video we are going to go over question number 4, free response section, AP Calculus AB 2023 exam. So let's get started. So what we have here is they have given us the graph for the derivative of a function. The y values, they are the derivative for a function f. What we are given with in the statement is the function f is defined on the closed interval. We have that closed interval here and satisfies this thing. F of 2 is equal to 1. Fine. The graph of the derivative consists of two line segments and a semicircle as shown in the figure. Fine. You got that graph over there. Does f have a relative minimum, a relative maximum, or neither at x is equal to 6? Over here. This place. Give a reason for your answer. Okay, we have to first of all tell them that if there is a relative maximum, minimum, or none of them at x is equal to 6, and of course we need to justify our answer. So, well, because this is the graph of the derivative, so we can see like at exactly 6, at 6, x is equal to 6, we have the derivative equal to 0. So the derivative is equal to 0. That means, yes, there is a possibility that it can be a maximum, minimum, or like neither, but we have to see if it is one of them. So what we can do is we want to see what's happening before x is equal to 6 and what's happening after x is equal to 6. By that I mean like we have to see the derivative, because you probably know, like if less you think of a maximum, so before x value where it's maximum, the derivative should be positive and after it should be negative, and for the minimum it should be negative before that value and after that value should be positive, right? So that means the sign of the derivative must change. So what we see here is that the derivative is greater than 0 for x less than 6. Well, we just want to see just before 6. Okay, so I'm just looking at these values. So it is positive, right? So you can, maybe you can say like it's positive just before x6, and it is still positive after x is equal to 6. So that means the sign of the derivative is not changing. So it's neither maximum nor minimum. Neither maximum nor minimum, right? And the reason we have explained earlier, if it is for maximum, should be greater than 0 before x value, whatever that value is, and it should be less than 0 after that. And for minimum, it should be less than 0, like negative, before that critical point, and it should be greater than 0 after that critical point. Okay, so yeah, you got the answer. Okay, now let's go over part B. Well, in part B, we have on what open intervals, if any, is the graph of f concave down? Give a reason for your answer. Again, like the answer and of course the justification. So we are going to see if it's concave down for some open interval. So concavity. For concavity, you have to see the second derivative, right? D squared f by dx squared, or like, or if we can also start like this or this, right? So no worries. So we have to see this one, and it should be less than 0 or concave down, right? And okay, this should be for the concave down. We are given with the graph of the derivative. That actually means if we take the slope, it gives us the second derivative, right? So if you see from -2 to 2, its slope is negative, and also from 4 to 6, it has a negative slope, right? So what I see from the graph is -2 to 0, is it 0 or yeah, -2 to 0, and also 4 to 6, these two open intervals, the second derivative is less than 0 as slope of this is negative. Okay, that's the answer. Now, part C. Well, in part C, we have find the value of this or show that it does not exist. Justify your answer. Okay, let's try to answer this part now. Well, this is the limit x approaches to 2, and then there is an expression. So, okay. The very first thing we do in limits is like we try to plug in the value, right? So if I just plug in 2, so it's gonna be 6 f of 2 minus 6, and over here it's gonna be 4. So 4 minus 10 plus 6 is gonna be 0 in the denominator, and f of 2, we already know that f of 2 is equal to 1. So 0 by 0, right? We don't need that. So what we can do, like, there are things that we can actually do. We can use L'Hopital's rule. So let's try to use the L'Hopital's rule. So if I try to use L'Hopital's rule, so it should look like something like 6, the second derivative, sorry, the first derivative, minus 3. I'm just taking the derivative in the numerator over there. 2x minus 5. Okay, and now if I just try to plug in the limits, so the second derivative, sorry, the first derivative at 2, so at 2 is going to be 0, right? So I'm just going to plug in the value. So this, and 2 times 2 minus 5, so it's minus 3 divided by minus 1, so it turns out that we get 3. Okay, that is the answer. Okay, find the value of the limit this or show that it does not exist. Justify your answer. Well, as x approaches to 2, this expression approaches to 3, and we have used the L'Hopital's rule. Is L'Hopital. Okay, fine. So that's pretty much it from C part. Okay, find the absolute minimum value of f on the closed interval -2 to 8. Okay, -2 and 8. So let's try to figure this out. Going to be the D part. We want to see like if there is an absolute minimum. Find the absolute minimum value of f on the closed interval, this one. Okay. The very first step, we have to see the critical points, right? So for the critical points, the first derivative should be equal to 0, right? So critical points, the first derivative should be equal to 0, right? So we're gonna have those first derivatives equal to 0 at x is equal to -1. You can see that. See the graph for first derivative. X is equal to 2 and x is equal to 6, right? Okay. Now, we have already discussed that at x is equal to 6, it's neither maximum nor minimum, right? So this is not possible. At x is equal to -1, if I just see it at x is equal to -1, the derivative before the value x minus 1, the first derivative is positive, and then after that value, the first derivative is negative. You can see it from the graph. It's already there, right? So that means this is also not possible because we are going to find the minimum, right? So we are left with only one option. We have x is equal to 2. But as you know that they are not asking about the relative maximum or relative, they are not asking about the relative minimum. Sometimes they call the local minimum. They are asking about the absolute minimum, right? So you have to see the endpoint behavior as well, right? So we just want to make sure that if the values for those endpoints, they are less than this or not, okay? So that means we have to see the function for x is equal to 2, x is equal to minus 2, and x is equal to 8, right? So we have to see these values, and only then we can decide if at x is equal to 2 it is absolute minimum, right? Okay, now if I have to find f of 2, what is f of 2? I believe they have already given us that value. F of 2, yeah. So we have f of 2 is equal to 1. Fine, we got that. Okay, now we want to get the value f of minus 2. What is it? Okay, now this is the graph for the derivative, right? So if I write this like, because the derivative and the antiderivative, they are going to cancel each other, right? Sort of like if you have a derivative and you want to like get the function back, you have to integrate it, right? Okay, so what we can do here is that, okay, we know like if you have a to b f derivative this thing, so this is actually equal to f of b minus f of a, right? Basic theorem. So what we can do here is, because I know I have the value of f of 2, so I can keep 2 as one of those limits, and the other limit I can choose as minus 2, and then I can actually see the area under the curve of this derivative, right? So because you are taking the integral, that means the area under the curve, right? So it's going to be something like, okay, minus 2 to 2, and this thing, it should be equal to f of 2, we already know that value, minus f of minus 2. Okay, so now what is the area under the curve? So from here and here, okay, so for the first one here, if you just see this one, this is a right angle triangle with a base 1 unit and the height 2 units, right? So it's gonna be 1 by 2, base is 1, height is 2 units. Okay, fine. And then there is another triangle, and it's the area under the curve is actually below x-axis, right? So minus 1 by 2. Okay, what is the base? 1, 2, 3 units, right? So 3 times. Okay, now how about the height? Is gonna be 2. Okay, so this is going to be the area under the curve, and f of 2 is already 1 minus f of minus 2. Okay, now just simplify this, and you're gonna see like f of minus 2 is equal to 1 minus, okay, this is going to give you 1, and here is minus 3. So 1 minus 3 is minus 2. So if you just take that over on this side, so minus 2 is going to be plus 2, right? So it's going to be 3. Yep. So we got that value as 3. Fine. So now let's do the same thing for x is equal to 8, the other endpoint. So I'm going to do the same sort of thing. And now from 2, because I already have the value for 2, right? 2 to 8, the derivative dx, it should be equal to f of 8 minus f of 2. Fine. Okay, now area under the curve from 2 to 8. Okay, first of all, see this triangle over here. Its base is 2, height is 2. So 1 by 2, base is 2, height is 2. Fine. Plus, okay, now to find the area for like area under the curve, here you can see like because like I know this is a sort of like curve thing, so you cannot directly find the area just by looking at the blocks, but you can see because it's a semicircle. So if I just take the total area as like a rectangle with the height 2 and its width is going to be like I don't know if you can call it width or length, 1 2 3 4 units, right? So the total area should be 4 times 2, right? 8. Fine. And then you have to subtract the area, this area, right, for the circle, and it's going to be the semicircle. So this is going to be pi r squared. Let's see what is the r. It's 2, right? So pi 2 squared, pi r squared divided by 2 because it's a semicircle, right? So it's going to be 2 pi. Fine. So it's going to be 8 minus 2 pi, right? So it's going to be 8 minus 2 pi. Why minus? Because you are looking for this area under the curve. Yeah, so it's gonna be this area, the purple one. So now it should be equal to f of 8 minus f of 2. F of 2 is 1. Okay, let's try to solve this. So 10 minus 2 pi, so 10 minus 2 pi is equal to f of 8 minus 1. Just take this 1 to the other side. 11 minus 2 pi is f of 8. Okay, so you got this. Now if you just look at these values, the endpoint and the value x is equal to 2, you can clearly see like the value at x is equal to 2 is actually less than the other two values, right? So yep, it is an absolute minimum. So yep, you have like absolute minimum at x is equal to absolute minimum at x is equal to 2 as the derivative is 0 and there is no other value less than this for the given interval. Okay, just complete that statement. So that's pretty much all of it. Yep, we have to justify your answer, like our answer. So yes, that is the justification. That is the first derivative 0 and there's no other value that is less than this thing. And you can also see like why we decided that it is going to be minimum. Like before that to the derivative, the graph of the derivative tells you it's negative, right? So after that is positive. So yep, that is minimum, right? For the minimum you have the slope negative before the critical point, and after that critical point it should be positive. Okay, so yep, so that's pretty much all of it. Thank you very much for watching the video and see you in the next video.